Ah, where'd I go? Oh, bloop. There I am. Okay. So on this last video, I'm going to talk about rotation matrices. They look a little bit more intimidating than the others because there's some math functions in there. And I'm going to start out with rotate z. So if you think about rotation in terms of three-dimensional axes, um, the z-axis is like pointing at you and away from you. So if you take that axis and you grab it and then you turn it, that's what the rotation is going to look like. So I have the c value here, and let's go ahead and see what that looks like as I start rotating. So you see I'm adding c here, this value of c, and I'm putting some arbitrary value there, and it's starting to rotate. And I have these cosines and sines mathematically placed inside of my matrix. But what's kind of interesting to note is on the rotate z matrix, if you think of these rows in terms of the x, y, and z, the x value and y value have things going on, but then this z value is 1, which means it's not changed. So that's a nice way to think about where those cosines and sines go to perform that rotation. And as you'd guess, looking at the y component here, it's going to be 1, and looking at the x component here, it'll be 1 as well. So you can kind of see the sines and cosines going there. And that's math, folks, so I'm not going to explain the math because I don't want to. Yeah, so the c component is a rotation using the sine and cosine, which is in radians. And so the unit we care about is 2 pi, which is 3.14 blah, blah, blah times 2. Another unit that you'll see if you ever read my code is I use tau to represent that, which is just a personal preference. Not a lot of people do it, but I like it. So there you go. So 2 pi, a full rotation would be, if I set that to 1. So that's a full rotation. You won't see anything. So 0.9 will rotate it back a little bit. So you kind of get the picture here. So let's set that back down to 0. And if you remember, matrices are, the order matters in how you apply them. So if we take this translation matrix, which I've set the x component of the translation matrix, again, x, y, and z here, I've done x out 200 units. So let's go ahead and take that, and we have our translation matrix, and let's go ahead and apply it. So I'm going to put it there and then save. And if again our rotate z is set to 0, so it works like we expected. It moves it over in that direction. And let's go ahead and multiply by rotate z first. So rotate z, let's go ahead and tweak some of this. So let's do a quarter turn here. And since we rotated first and then moved it, you can see it rotated about the origin. But if I wanted to rotate about here and then swing it out like it's an arm, I would switch the order so that I would translate first, then rotate. And if you notice, this is going to look like it's going to be going around a circle. So if I do 1 here, and then go to 2, 3, 4, you can see it's rotating about that origin. While if I switch that order, you would see it'd be back to the original spot, but rotated in place. So the way to think about working with these is you might have some point out here, but if you want to rotate it around, you have to move it back to the origin, rotate it, and then put it back to where it was in order to get the correct rotation if you want to rotate it in place. That's some of the weirder things with working with matrices, especially if you have to like do it. If the multiplication is in reverse order, it gets even more confusing because you're like, okay, like which way do I go? So usually I like to start with one small matrix that I know how it works, and then very carefully place the second one there to see how it multiplies correctly. And a few times, just because the way math works, it surprises you. You know, small little steps there. But yeah, matrices are really helpful because you can have just a set of 16 numbers that you can combine them in any way you want and just keep on doing it, and then it preserves those steps of those transformations. So it preserves your history. You can save certain parts of the way you've moved things about the scene in a single matrix, break them out into separate little steps and components, put them back together. So it's an extremely useful tool for doing 3D work, and it's only 16 values that are saved that are just right next to each other. So just 16 numbers in a row, and there are even more different types of matrices with like perspective that's beyond the scope of these few short talks. So anyway, I hope you found that helpful.